We're going to solve for homework 9, number 4. So first off, we're going to make this homogeneous. So we have y triple prime minus y prime is equal to 0. We're going to plug these in. We have d cubed minus d of y equals 0. So this tells us that our f of d is equal to d cubed minus d. Now we're going to get our characteristic equation, which is m cubed minus m equals 0. We can factor out an m and get m squared minus 1 is equal to 0. So our m values are going to be 0 and plus or minus 1. This will tell us our fundamental solution homogeneous is 1 e to the x and e to the negative x. So this will tell you our general solution, which we also refer to as our YC, is going to be C1 plus C2 e to the x plus C3 e to the negative x. Now we will solve for our non-homogeneous version, so I'll rewrite the problem. Our annihilator, or Annie as we refer to it as, of e to the x is d minus 1, which is also going to be equal to our g of d. So now we're going to multiply f of d and g of d. You don't actually have to multiply these because they're already factored out. So we're going to say d cubed minus d and d minus 1. Well, we know the d cubed minus d is also in our m form, m cubed minus m and m minus 1. We factored this out earlier to be m squared minus 1, and this one is still m minus 1. All of these are equal to 0. So our m values are going to be 0, plus or minus 1, and 1. So now we can find our fundamental solution non-homogeneous, which is 1 e to the negative x, e to the x, and x e to the x. So now we're going to do our fundamental solution non-homogeneous minus our fundamental solution homogeneous, which is our non-homogeneous fundamental solution rewritten. So 1 e to the negative x, e to the x, and x e to the x, minus 1 e to the x, e to the negative x. Some of these should cancel, so we can get rid of this one, this one, this one, this one, this one, and this one. So now we're left with x e to the x. So now we can solve for yp, which is equal to x e to the x times d1. d1 is just a constant. So we're going to find our yp prime, which is equal to x e to the x d1 plus e to the x d1, and yp double prime, which is equal to x e to the x d1 plus 2 e to the x d1. So I'm going to flip the page over. We'll find one more, which was yp triple prime, which is going to be x e to the x d1 plus 3 e to the x d1, because essentially we're trying to solve for yp triple prime minus yp prime is equal to e to the x. So when we plug this back in, we get x e to the x d1 plus 3 e to the x d1 minus x e to the x d1 plus e to the x d1, which is all equal to e to the x. As we can see, some of these will cancel out. This x e to the x will cancel with this one. We're left with 3 e to the x d1 minus e to the x d1 equals to e to the x. This simplifies down to 2 e to the x d1 is equal to e to the x. We can divide both sides by 2 e to the x. This is going to leave us with d is equal to 1/2 because these ones will cancel. So now we plug d1 back into our yp, which we previously said right here was equal to x e to the x d1. So now we have x e to the x times 1/2. So this is all 1/2 x e to the x. Now we can find our general solution, which is y equal to yc plus yp. So earlier we found our yc, which is c1 plus c2 e to the x, with c3 e to the negative x, and now we'll add in our yp, which is 1/2 x e to the x, where c1, c2, and c3 are arbitrary constants.